Well, hello again, welcome to the VK6CS Amateur Radio channel. I'll give this a crack, but the tripod is in the wrong place. I'll have to see if I can find out if there's a way where I can invert the image on this and then have the camera on the other side of the board. Maybe that's the way these things are generally done, but then, you know, I've done so few of them, I don't really know. I'll just give this a crack and see how it looks. Yeah, I might get away with it. Now, I've been thinking about switching the amplifier in and out. So to do that, I'm going to need a couple of relays to actually do the signal switching. So in order to do that, I would have to have, the signal path, the switch signal path would be input. That will come into a relay, which will then go to another relay, to the output, and we would have there's a chassis connection there as an input, there's an output, there is the amplifier, and we'll call that relay 1, that relay 2, that'll be input, and that'll be output. Now I'll just have a very quick look at how that looks. Actually, that's not too bad. I think you can get the gist of that. So what actually happens when the amplifier is keyed? The relay coil for the input relay, relay 1, and the coil for relay 2 are energized, so they will go off to plus 12 volts in this case. And the way these will be energized is these points here will be taken to 0 volts to energize the relays, and they would then pull that in, the input relay and the output relay, to switch the amplifier in line. And that's done by the drive radio. The drive radio has an NPN switch in it, little NPN transistor in there. I'll have a diode across it. That's the drive radio. Okay, and what actually happens, so it's not a relay contact in the drive radio, it's an NPN switch, solid state switch. So when you press the PTT, this transistor turns on and it takes that line there to 0 volts. So if you've got your amplifier relays hanging on there, it'll take them to 0 volts. Now, I looked at an FT817 circuit diagram. This device is 160 volt device at I think 5 amps, fairly substantial device. But even so, and chances are it's going to be the same in an 857. I'll be using an FT450. I suspect the device is probably going to be the same in that. They're all made by the same company and the device is doing the same job. So I thought, well, you know, rather than have the relay current going through, you know, down the cable into the drive radio through the little switch, I'd have a smaller relay. I'd have one small relay that would actually activate my input and output relays. So then I thought, well, rather than have them both activate at the same time, I'd actually read somewhere that it's a good idea to have the output relay make just a millisecond or so before the input relay makes. So when you press the PTT line, the output relay is connected to the output of the amplifier just a millisecond or so before the drive is applied to the amplifier, and it's a lot more convenient for the for the valve and for the relay, not to have to, you know, the valve doesn't want to operate with no load, and the relay doesn't really want to be switching the valve once it's being driven, even though this is going to be a vacuum relay. It's nice if the relay is made before the power is applied. So I thought, and I'd seen a couple of solid state circuits to achieve that, and I thought, well, rather than do that, I think there's an easier way of doing that. And I thought, well, if I have an activation relay, just a little relay, little activation relay, like that, and that would go to my drive radio. So the PTT on the drive radio activates this little activation relay, and the little activation relay would have a contact that goes to 0 volts, and that will come along here, and the first thing it would do is activate this is the coil for this relay. So as soon as this makes this coil makes that contact, so the output's connected. I thought I would also put another small relay hanging off that 12 volts, so that would activate at the same time, and what that does is that would have a 0 volt contact on it as well. And that would come around to there. So what happens is, you press the PTT, the relay activates, that's the first one that activates, then you've got 2 and 3 activate, and then 4. So you activate the first relay, very small relay, that makes, so it's not putting any stress on the drive radio. This contact makes, switches on the output, switches on, activates another relay, which then takes that coil to deck and activates the input. And all this is doing is putting in a slight delay between the output relay being made and the input relay being made. That's all it's doing, but it's doing it without any components. You know, I just want to keep it as simple as possible, and the simplest way to put a delay between the output relay activating and the input relay activating is just have another little relay in there. So that's what I've got in mind for the amplifier switching. Sounds like I'm standing on a bag of crisps. I don't know what the hell that is. Oh, it's another sponge. There we go. Okay, so that is what I've got in mind for the input and output switching. Probably looks a little bit like a, I don't know, like a bird's nest, but I'm sure you can see where that's going with that. Now, what do these bits look like? That's a very good question, and one I can hear from here. Incredible. Let's reach through the high voltage power supply, and this little relay here would be in that position. I don't have the other one yet, but there'll be another one of those in that position. Now, my vacuum relay, as used by some of the commercial ham amplifier manufacturers, this is a little vacuum relay. Probably get that rustling. It's like Christmas, isn't it? You know, rustling in the background. It sounds like a goodie is about to be produced. And there we go. Get to where I can actually see it. I don't know if it's going to focus on that. There we go. Got 3 contacts there. and that's a panel mount 12 volt vacuum relay. So that will be there, like that. Now when it comes to the input relay, I've got a couple here. Now what I don't quite understand, I'll have to have a look at the, I've got the specification sheets for both of these relays. I've got one here that's rated at, believe it or not, this one is rated at 300 watts. I'll go there. Actually, it'll go like that. Probably a little more obvious when you see it like that. Now, what really surprises me, and this is the box that it comes in. As you can see, it's upside down, of course, but I am in Australia. Bear that in mind. There you go. That's a fairly small box. Now, I've got one here that's in a bigger box. Now, I haven't actually read the specification sheets carefully. I will do tomorrow. Although the Handfest is on tomorrow, so it might get left until during the week or next weekend. But that's a bigger box, as you can see. And what's inside actually looks a little more substantial. What's inside looks a little more substantial. It's got end connectors on it, not BNCs. You know, it's got looks like quite a nice. In fact, I might use this one. But strangely enough, so you can see you've got the common there, and the two switching points there. You can actually see the relay there. So that's a very similar thing. Now, believe it or not, that big one I put down, and I have got the specifications the right way round. This is definitely the right model number. It says maximum input power. Now, what I don't quite get with this, and I think this is probably a translation from Chinglish, it says maximum input power 150 watts DC at 1000 megs. So it's not going to be 150 watts DC at 1000 megs, is it? You know, it's going to be 150 watts input, RF input at 1 gig. Now the other one, the small one, says, what does the small one say? Small one says maximum input power 300 watts DC at 500 megs. So 300 watts, so 300 watts of RF at 500 megs. Oh, I see, okay. So the reason the other one's bigger and handles less power is because this one will work up to 1.5 gigs and that one there will work up to 2.5 gigs. So it's a frequency thing. Okay, so I'll use the smaller, I'll use that one because that one there is rated at 300 watts. As far as HF is concerned, could probably get away without using a coaxial relay there. I mean, the vacuum relay, my vacuum relay here, as you can see, is not a coaxial relay, but I might mount that in a little box so that that's actually got, I don't know, either an end connector or an SO239 for the actual RF output, and a couple of BNCs as well for the through and to the amp. So this might just be a box with two of these connectors on it and one SO239, if you see what I mean, and that will be over there. But these vacuum relays are used, as I say, I don't have the spec for that handy, but I did look at it and it's fine. It's going to be fine for switching that output. It's not a problem. So there we go. So there are the there is the sort of proposed switching arrangement and what the switching components look like. And I think that's going to be the best way to do it. As I said, what this arrangement will do is ensure the output vacuum relay connects a load to the amplifier, a millisecond or so before the drive is applied, and by using the small switching relay, two of these, one here and one there, I'm putting a really minimal load on the keying line into my drive radio NPN switch. So there we are. That's what I got in mind. So I hope you found that interesting. And as always, thanks for watching. I'll catch you next time.